Okay, we are working on the naming ionic compounds practice worksheet. And so all these will be ionic compounds, which means we will not be using prefixes for any of them. So NH4 is a polyatomic ion, and that's ammonium, and Cl is chloride. So ammonium, you only have to check for Roman numerals if it's in that one area of transition metals. Like this one for number 2. If we look at the periodic table, we find that iron is right here. That means you have no idea what the charge is by looking simply on the periodic table. So that means we're going to need an area for the Roman numeral. NO3 is a polyatomic ion, and that's nitrate. Now, in order to figure out what the Roman numeral is, we have to look at the subscripts. In order to get those numbers down there, to make them subscripts, we use the charges. We're going to reverse that action to make them, to turn the quantity into charges. And if we look at nitrate, we know that nitrate's supposed to be a -1. That means that this is just fine, and iron is a +3 charge. So I'm going to put a Roman numeral 3 there. TiBr3. Ti is titanium, and it's right here. Once again, when you look on the periodic table, you can't determine what the charge of titanium is by what row it's in. Therefore, we need a space here for the Roman numeral. And then Br is bromine, and it becomes bromide. So we have an invisible 1 here. We're going to uncross it just like we did up on number 2, +3 and -1. This time we're going to check bromine to make sure it's the right charge. Bromine is here. It's supposed to be a -1, and according to this, it is. So that's fine. That means our titanium is a +3 charge. Copper is right here on the periodic table. Once again, you cannot determine the charge just by simply looking at the periodic table. That means we have to write down the charge as a Roman numeral. And P is right here, and it's phosphorus, and it becomes phosphide. When we uncross it, there's an invisible 1 here, so that becomes +1 and a -3. Phosphide is supposed to be a -3, so that's good. So that means copper is indeed a +1 charge. Number 5. We have tin, which is down here. It's in the same row as carbon. Now you'll notice that there's actually no charge to memorize for that family. That's because that family also changes. And then selenium, which becomes selenide. We need to figure out the charge of tin because that is a transition metal, even though it's not in this area here. This row is the other row of transition metals. There's an invisible 1 here, so that makes that a -1 and a +2. If we look at selenium, however, selenium's right here. It's supposed to be a -2. Because it's actually a -1 according to our uncrossing, we're going to have to multiply both of them by 2 to make that a -2, which means that tin is actually a +4, not a +2. And then GaAs. Ga is gallium. It's right here. And As is arsenic. It's right there. Gallium is in the +3 row, so that means we do not need the Roman numerals because it's always going to be a +3. So, gallium, we don't need a Roman numeral. Arsenic becomes arsenide. Number 7, lead is right here underneath carbon. That's going to be another one of those transition metals that we need the charge for. So we need to leave a space for the Roman numeral. SO4 is actually sulfate. So when we uncross this 2 outside of sulfur goes up to the lead, and this invisible 1 from lead goes up to sulfate. You'll notice that sulfate is supposed to be SO4 minus 2, but right here we have it as a minus 1. That means we need to multiply both of these by 2, because that means it must have been reduced. That means the Roman numeral is actually 4. Looking at the periodic table, beryllium is right here. It's in a +2 row. That means since I can look at the periodic table and tell you what the charge is, automatically we do not need the Roman numeral. HCO3 is bicarbonate. Because I don't need the Roman numerals, I don't have to do anything with the crossing or uncrossing. Mn is manganese, and it's right here. And you cannot determine the charge of manganese just by looking at the periodic table. So that means that I do need to figure out the charge. SO3 is sulfite, and it is SO3 with a -2 charge. So that's sulfite. So I need a space there because it's right here on the periodic table for the Roman numeral. When I uncross it, that 3 goes up here for manganese, and the 2 goes to sulfite, which is exactly what it's supposed to be. So I don't have to change anything. It's just going to be manganese 3 sulfite. And the last one for this video is aluminum cyanide. Aluminum is here on the periodic table. It's a +3. Because I was able to look at the periodic table and tell you the charge, that means I do not have to worry about that Roman numeral. I can just go straight to the anion, which in this case is cyanide. And that is the end of numbers 1 through 10 for the naming ionic compounds worksheet, and we're going to do 11 through 20 in the next video.